Thank you. So I'm Hamza Harkous from EPFL, Switzerland, and I'll be presenting our work on dissecting and mitigating the privacy risk of personal cloud apps, or what we call the curious case of the PDF converter that likes Mozart. This is joint work with Ramiz and Boyan and my supervisor, Carl Aberer. So in this research, we target third-party cloud apps. Typically, users have been uploading files to cloud service providers like Dropbox and Google Drive. Nowadays, there's actually a growing ecosystem of third-party apps that connect to Google Drive or to Dropbox and access users' data from there instead of the users putting data from their desktops. And this allows users, for example, to edit photos just directly by importing them from Dropbox or to sign PDF documents, etc. However, with this growing ecosystem, we have a new problem. Instead of users seeing their privacy as threatened by one adversary, it's now thousands of adversaries. And these thousands of adversaries are more powerful or more dangerous than the traditional cloud service providers because these are less accountable and generally they are less secure and they don't usually have privacy policies. This is in the wild, an ecosystem in the wild. And that's why people have been complaining because people store a wealth of data like medical, financial data on Dropbox and Google Drive. And actually they complain on social media like they post screenshots of apps requesting extra access from their files. And that's something we were motivated by. Accordingly, we tried to ask ourselves the following research questions. First, how much do these third-party apps, how much access do these third-party apps have? Second, can we do something to deter users from installing overprivileged applications? And third, can we infer something about the developers' behavior with these third-party applications? So beginning with the first question, how much access? We took Google Drive as our case study, which is one of the most famous ecosystems. Google Drive basically has two levels of access when it comes to data itself. So there's per file access. Users authorize the application to access only specific files. Explicitly, they specifically say, this file you can access. There's also full drive access. The app can access all the files in users' Google Drive, including the content, their list, etc. There are other types of access, like metadata access and access to the list of installed apps. Google also recently introduced Google Photos specific access, but this has not yet been used a lot by developers. These were the main access levels at that time. So in order to analyze and to quantify the risk, we actually checked the 100 top featured apps, Google Drive apps, on Google Chrome Store. There's a section for that on Chrome Store. And for these apps, we compared the requested APIs, that is what the app actually displays to the user, I want these, with the needed APIs. So for the requested APIs, we went to each of these apps on the app's website, and we check what permissions it needs. We try to sign in, etc. And for the needed, to know what are the needed APIs, we did permission reviews. So we checked the interface of the application and how it accesses Google Drive. I will explain that now. Just a note that it is challenging to do this on a large scale with the cloud apps. It's not the same as in Android apps or in other ecosystems. I can answer and explain that more offline or in the questions part, but this is just a note about this. So this is an example of an overprivileged application. So you go, this is a PDF to Word converter. You go, you connect it to Google Drive. It asks you, I want to view and manage all the files in your Google Drive, just to convert a PDF to a Word. Then I allow it. Now, you will see now that the application redirects me to an interface. This interface is provided by Google. So Google provides this interface as a mediation between the user and the application in order specifically to allow per file access and not full access. So when an application uses this interface solely, it needs per file access, not full access. By comparison, this is a least privileged app. This is only Office. It's an Office viewer application. So you go to the application, also connected to Google Drive, and it also requests full access. Now the application, you will see that it does not redirect to any Google interface. So the application has to download all the list of files and folders and show them to you in the interface. And then you can open the file all in the application. So the app is actually connecting to the API, requesting each and every file without you intervening. This app actually requests and needs full access. Based on this rationale, and we classified, or we decided whether the apps are overprivileged or not, and what permissions they actually need. If the interface is mediated by a Google interface, then the app needs per file access. If not, and the app doesn't use the Google file picker, and it needs the functionality, it needs the content, then the app needs full access. We have more explanation in the paper about the decision methodology. As a result, we found the following. 76 of the 100 featured apps on Chrome Store were overprivileged. That is, requested full access while they needed per file access. Now, the most surprising result was 64% of these apps were overprivileged, and all of the overprivileged apps requested full access. So as a result, almost 84% of full access apps were overprivileged. That motivated us to try to help users avoid overprivileged apps. And this is our approach was basically to try to add new privacy indicators to communicate the risk in a better way. So this is the current interface provided by Google. It has the list of permissions to authorize. Now, what we did first is that we introduced the first privacy indicator. It consisted of splitting these permissions into the unneeded permissions and the needed permissions. So in the same way we have labeled the permissions before, we did also labeling here to know what permissions are needed and not, and we integrated that into the interface. So this is the first interface we wanted to test. This is what we call the delta permissions model. That is the delta which is unneeded, is told to the user. Now, we take this delta permissions and we added something else. We answered the following question in the interface. What do the unneeded permissions say about you? So we told the user this information will be relayed to the application or to the company. The first type of answer we've provided is what we call immediate insight. That is direct examples from the user's data. So for example, photos that the user has taken and put in Google Drive, or actually locations that the user has been in based on location metadata of photos in Google Drive. We also showed excerpts from files. These are directly extracted from the user's Google Drive. Now we had another thing, which is far-reaching insights. We answered the question in another way. Based on analyzing the user's data, we could, and the app itself could get more insights about the user. So for example, the app can know what entities, concepts, and topics are interesting to the user. And that's something we displayed in the interface. We also showed the user what sentiments could be extracted from their documents, if they are pro something or against something. We showed the top collaborators they work with, what shared interests they have with these collaborators. In photos also, we showed what are the top faces that appear in users' photos, and what objects appear with these faces. This is another interface. We call it faces with context. And finally, we put these faces on the map where they were taken. The photos were taken there, so we put them there, and we also showed this insight to the user. So we ended up with 4 models: the baseline, delta, immediate, and far-reaching. Now we wanted to test them. So in the user experiment, we had 4 groups corresponding to these four models. The first group, in the first group, we had the baseline, and in the others, we had the other new indicators. Each group had one model. We didn't have mixed models among groups. But the immediate and the far-reaching insights had the different visuals corresponding to the immediate and far-reaching insights. That's why it's a split plot design. 210 users were recruited mainly via university mailing list. We also got users from participants from tech websites. And then we did the experiment. The experiment consisted of a list of tasks. So tasks are app installation tasks. So for example, select the app which allows you to extract the zip files in your Google Drive. The user would go and will see an interface similar to a Chrome store. And based on the permissions, they are asked whether they are think the permissions are too invasive or they're okay, so whether they accept or reject, and so on and so forth. This is one task of the list of tasks given to the user. So the first finding I want to talk about is the following. So first, just the metric we use in our results is the acceptance likelihood. That is, what is the percentage of participants in each group who would still accept the overprivileged applications versus the ones who reject. So the baseline model and the delta permission model were pretty close. Actually, surprisingly, the delta permission model didn't help. That is, telling users only that this app needs unneeded permissions didn't help much. However, the immediate insights interface helped twice to actually reduce by a factor almost of 2 the acceptance likelihood. So it was very effective. And even more effective was the far-reaching insight. So far-reaching insight on average was significantly more effective than immediate insight, which was significantly more effective than delta and baseline too. The second outcome of our experiment was that we noticed the following. Relational insights, that is, insights that describe your relations with others, that is, whom do you go out with, what shared interests you have, were actually the most effective. The most effective in deterring users from installing overprivileged applications compared to personal insight that describe what you are interested in. The second thing was that face recognition helped a lot compared to just displaying the image. So using data analysis in the case of photos was very effective. In the case of text, we couldn't detect a significant difference. But we also noted that it was close in terms of the percentages. But we can't say much there. So actually, we developed the far-reaching insights, and we put them in an actual store. So Privy is a store, acts like a privacy assistant for installing cloud apps. It has been up since June 2015, and it has over 1,600 users. So you go to privacy.epfl.ch after you sign in, etc. You can search for applications. For example, you search for a PDF, and then you view the list of apps that are match your query. You can filter them by good apps and apps requesting more than they need. You can see also what apps do you have and see whether they are overprivileged or not. But you also see everything within this new permission model. Now, the third thing and the last thing is that can we infer something about developers' behavior? Based on Privy, we collected actually an app data set. So we asked users to grant us access to the list of apps. And then we analyzed this anonymized data set to discern into the developer's behavior. The first outcome here was that over 40% of apps on Chrome Web Store changed their access level with time from partial to full access, or the reverse. Actually, 94% changed from partial to full access, and 6% the opposite way. How did we find that? Actually, when users install apps, it's recorded in their it's recorded whether the app at that time was partial or full access. And we had users installing the same app. So we saw for some users it was partial, and for some users it was full. Then we checked what it is now, and then we knew whether the app has changed from full to partial or partial to full. Another finding was that apps that are outside the Chrome store tend to request full access much more than apps inside the Chrome store. So the store, as expected, acts as a deterrent to developers, actually, in order to not request full access. That's some explanation we came up with. that was the answer to the third research question. Okay, so just conclusion. Finally, transparency dashboards are a way we suggest also to allow users to know what apps have access from their data and when. So this acts as also a deterrent for developers to misbehave. Okay, so this is my talk. These are the conclusions. 2/3 of the apps on Google Drive were overprivileged. Users' data as a language for risk communication is effective, and developers are actually escalating their permissions. Thank you, and if you have questions,